Hello learner, it is time for our SHS 3 Core Mathematics program. This is brought to you by Senlos. I am Ben Apeudatson. In our previous lesson, we learned about surface areas of a cone and how to solve problems involving surface area of a cone. In this lesson, we shall learn how to find the volume of a cone. By the end of this lesson, you will be able to calculate the volume of a given cone. Now let's look at how to find the volume of a cone. The derivation of the formula for a cone is actually above the scope of this lesson. However, there is a simple activity that can help us know the formula easily based on our knowledge about the volume of a cylinder. Consider a right circular cylinder and a right circular cone of the same base radius and the same height. We will illustrate this in the diagram. So we have a cylinder and a cone. They have the same base radius and the same height. Let's go through these activities. First, we will make a hollow cylinder and a hollow cone. The first step is we fill the cone to the brim with sand and we pour it into the cylinder. As you can see, we have poured the first sand from the cone to the cylinder. Step 2, we fill the cone again to the brim and then we pour it into the cylinder again. Now you can see that the level of the sand will rise to a certain level in the cylinder, as you see on the screen. Then we fill the cone again with sand and pour it into the cylinder. Now you see the end of our activity. At this point, it can be noticed that the cylinder is also full to the brim. What is your observation? It can be observed that the 3 times the volume of the cone make up the volume of a cylinder, which has the same radius and the same height. In other words, the volume of a cone is 1/3 the volume of the cylinder. For our lesson on prisms, we were able to establish that the volume of a cylinder is given by V equals pi r squared h. We can deduce the formula for finding the volume of the cone from the observation we made from the activity as V equals 1/3 pi r squared h, where r is the radius, h is the height, and pi is a constant. So you realize that the volume of a cone is 1/3 of the volume of a cylinder. Shall we take a few examples? Find the volume of the cone shown on your screen. This cone has a base radius of 7 centimeters and a height of 14 centimeters. We take pi to be 22/7. Now this is the solution. From the diagram, the height is 14 centimeters. The base radius r is 7 centimeters. Therefore, the volume of the cone, which is 1/3 pi r squared h, making the appropriate substitution, we get V equals 1/3 multiplied by 22/7 multiplied by 7 squared multiplied by 14. And when we use our calculator, we will get V equals 718.67 centimeters cubed. That's very simple. Let's take another example. A cone is 14 centimeters deep and the base radius is 4.5 centimeters. Calculate the volume of the cone. We take pi to be 22/7. Now the solution is like this. From the question, The height of the cone is 14 centimeters and the base radius r is 4.5 centimeters. The diagram, you can see height 14 centimeters and radius 4.5 centimeters. Using our relation V equals 1 over 3 pi r squared h, we do the appropriate substitutions and we get V equals 1 over 3 multiplied by 22 over 7 multiplied by 4.5 squared multiplied by 14. With the help of our calculators, we get V equals 297 centimeters cube. That is straightforward. Maybe the third example. A solid cone of height 63 centimeters and base diameter 54 centimeters is formed from a cylindrical drum equal in height and diameter with the cone. Find the volume of the remaining parts of the drum. Again, take pi to equal to 22 over 7. I hope you can try this. Let's look at the solution. We will first draw diagrams to illustrate the question, as we always do. In mensuration, anytime you are given the question, you try to draw the diagram. That will make the question a little clearer. So you see our diagram. You have the cylinder of height 63 centimeters and diameter 54 centimeters. And we have shown our cone in the cylinder. When we pick the cone out of the cylinder, you see the cone shown in figure B. Now you see the remaining parts of the cylinder with the cone taken out. Now diagram A represents the cone formed in the cylinder. Diagram B represents the cone which has been removed from the cylinder. And diagram C represents the remaining cylinder. Now the question is to find the volume of the cylindrical drum and the volume of the cone. So the volume of the cylinder is given by, as we know already, V equals pi r squared h, where r is the radius and h is the height. But from the question, we have been given h equals 63 centimeters and r equals 54 divided by 2, because the 54 was given as the diameter. So we divide by 2 to get a radius, and that gives us 27 centimeters. We then do the appropriate substitutions, and we have volume equals 22 over 7 multiplied by 27 squared multiplied by 63. Therefore, V is equal to 144,342 centimeters cubed. So the volume of the cone is given by V equals 1 over 3 pi r squared h. So you have V equals 1 over 3 times 22 over 7 multiplied by 27 squared multiplied by 63. And that gives us 48,114 centimeters cubed. We are to find the volume of the remaining part of the drum. We have found the volume of the entire cylinder, and we have found the volume of the cone that we removed. So to get the remaining part of the drum, we will subtract the volume of the cone from the volume of the cylinder. So the volume of the remaining part is equal to 144,342 minus 48,114. And that gives us 96,228 centimeters cubed. Alternatively, we have learnt that the volume of the cone is 1/3 the volume of the cylinder. Therefore, if you remove the 1/3 from the whole, then the volume of the remaining parts will be 2/3 of the volume of the cylinder. So we can also state that the volume of the remaining parts is 2/3 pi r squared h. We know our r, we know our h. So if you do the substitution, you get V equals 2 over 3 multiplied by 22 over 7 multiplied by 27 squared multiplied by 63. And when you use our calculator, that will give us 96,228 centimeters cubed. So this is an alternative solution, an alternative way that we can solve the same problem. Shall we consider the last example? A cone of height 8.5 centimeters is mounted on a tent which is cylindrical in shape. The diameter of the tent is 22 centimeters and its height is 4.5 centimeters. Given that the diameter of the cone and the tent are the same, find the capacity of the tent. This is a very nice problem. I hope you understand the rudiments. Let's see how the solution goes. First, we need to draw the diagram. And you should be able to draw the diagram. Always try as much as possible to draw your diagrams. Now, this is our diagram. There's a base diameter of 22 centimeters. The height is 4.5 centimeters. And the height of the cone is 8.5 centimeters. We find the volume of the cone, and then we find the volume of the cylinder. Then we put the two together to give us the volume of the tent. We know the volume of the cylinder is V equals pi r squared h. In this case, our h, which is the height, is 4.5 centimeters with a radius of r, which is 22 over 2. Because we were given the diameter, so you have to divide by 2 to get a radius. And that gives us 11 centimeters. We do the appropriate substitutions, and we have V equals 22 over 7 multiplied by 11 squared multiplied by 4.5. And that gives us 1,711.286 centimeters cubed. Now the volume of the cone. We know that is 1/3 pi r squared h. So we do our substitutions, and we have 1/3 times 22 over 7 multiplied by 11 squared multiplied by the height, which is 8.5. Using our calculators, we have the volume to be 1,077.476 centimeters cubed. Therefore, the total volume of the tent, which is the cylinder and the cone, is 1,711.286 centimeters cubed plus 1,077.476 centimeters cubed. If you put the two together, you have 2,788.76 centimeters cubed. That is the volume of the tent. I hope that was very, very easy. Very, very simple. In calculating the volume of a cone, we know it is 1/3 of the volume of the cylinder. In this lesson, we have learned how to derive the formula for calculating the volume of a cone. We have learned how to find the volume of a cone. We have also learned how to apply the formula in solving problems. This brings us to the end of our discussions on volume of a cone. In our next lesson, we shall learn about other solids, such as the pyramid. I hope you have learned a lot, and you will keep practicing a lot more questions on all that we have been discussing on this program. Join us again for the next lesson. See you then. Goodbye.